Hi everyone, welcome to my channel, M's Tech. Today we are going to talk about a fairly new programming language. When I say fairly new, I would say it's about roughly 8 years into the planet being born. It's 8 years old, and what it claims is it's about empowerment. It's Rust programming language, and a very interesting client about it is the Gork AI, like the rival of ChatGPT that Elon Musk has just introduced, Grok, artificial intelligence prompt engineering, and those kind of stuff. They use Rust programming language. Now, why is it better than the others? It gives you the tools to do low-level programming without having to deal with the problems that usually low-level programming has, like, say, for example, C, C++, C#, all those, where you can directly deal with memory, right? Probably Java, which has garbage collection and all those. Rust takes away all the disadvantages or most of the disadvantages that these programming languages have and offers you very fast programming environment. Okay, so when you deal with low-level languages like C, where you have to deal with your own memory management, data representation, you need to handle concurrency, everything which we dread in a programming language, right? How are we going to manage the memory if there's memory leakage, or how are we going to handle concurrency? I mean, of course, there are tools, but it's always what you call error prone. So Rust breaks down these barriers by eliminating the old pitfalls, and it provides a polished set of tools or advanced set of tools to help you overcome these problems. Now, there is no garbage collection in there yet. The language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. All right, what we can do with this, let's see some examples, or what you call a little bit more in detail about the programming language. And let me share my screen. All right, hopefully you can see the screen here. And let's go here. Yeah, so we just talked briefly about Rust programming language. It's been around 8 years. Claims to help speed the development, speed the program execution time, take care of memory management, take care of concurrency. Okay, lots of advantages. Because it's new, it has taken, what do you call, into consideration all the problems that the old programming language had and made sure that this language does not have the same shortcomings. So it's a modern systems programming language focused, you have to see, about safety, which deals with memory management, right? You can do that safely in Rust. Speed, because it's in memory, very much at fast speed, and it handles concurrency. It accomplishes these goals by being memory safe without using garbage collection. It helps you write faster, more reliable software. As we'll see later, okay, as we advance into learning this language, we'll see how it is providing you, or how it is actually better than the previous languages. It gives you the option to control low-level details such as memory usage, and without the hassle of traditionally associated with such controls, without the hassles, right? Like you had the pointers, and then you had to make sure release the pointers, and JVM had to run garbage collections to free up the variables that are not used, or release the memories that the variables that are not used pointing to. Okay. So any programming language, you got to install it. Very simple way to install. This is, you're going to run the curl command. Okay, you can take a note of it, and it will install the version. So see, if you're installing, welcome to Rust. All what it installs is, it installs cargo, which is its packaging system. It installs Clippy. It installs Rust doc. It installs a compiler. It installs a formatter. So many things it installs. It updates your path environment variable. So make sure you're running it, this command from your home directory, because it'll try to access .bash profile. And if it cannot find bash profile or .rshc, it'll complain. All right. And then you can set the cargo. We're going to learn cargo a little bit in detail, or in the next lecture, actually. Okay. Which is generally used to create projects, run them, execute them. But we're going to learn more about detail later. Finally, you see Rust is installed. Great. So first program. Rust programs have .rs extension, like how Java file had .java. Main is the main function. Again, similar to Java, like you had public static void main, which was the entry point of any program. Here also, it's a special function main. Command println, which is also called as macro. Macros, I believe they are executable, small executable codes, and all macros are end with an exclamation here. Do you see the exclamation? Yeah, that's how the macros end. Command, the macro name, exclamation, and the parameter. You can see string enclosed in double quotes, sentences ending with a semicolon. Once this program is written, you can save it. Because we downloaded Rust compiler too, you have to compile, giving it the file name. It creates an executable, and you can just run it .hw. Okay, a native executable file which you executed. Now this would be similar to how you do Javac, right? Going on to a little bit more details. What are the data types? There are scalar data types and there are compound data types. Again, as the name suggests, these are very, very, very similar to any programming language which are there. Like you have the primitive data types and object data types, right, in Java. So there are signed integers, unsigned integers, floating points, characters, Boolean, and unit type. In compound, you will have arrays, you have tuples, right? And these 8, 16, 32, they're nothing but the size, okay? Bit size. So 8 bits, 16 bits, 32 bits, same thing for the others. This is just another function. We will see this actually in action. You can see, so how you will define a variable. It's let variable name colon data type equal to values. Now here, you have to note in Rust, I mean, it's there in the next slide, but variables are by default immutable. Well, immutability has a lot of advantages, right? It comes with a lot of advantages. Makes it thread safe, makes your program more predictable. Like you can be 100% sure no matter how many times you run the program. Given the same input, the output will never change, right? That's immutability. Like once a value is assigned, it cannot be changed. So that is by default. Okay. Here, f float 64, just a regular value. You can also give it, you know how when you declare a hex variable, you give OX in Java, like saying that this is a hexadecimal. Similar here. So let an integer is equal to 5 with its size 32 bits. Okay. If you don't give, default will be used. So default for float is 64 bits. For integer, it's 32 bits. You can also infer the type. So here, oh, but one more thing before we see, look here. There's some additional word here, MUT. What does this mean? It means that this variable is mutable. So in programming languages, there might be many times, many use cases where you do need to change the value of the variable, okay, depending upon the use case. Now, if it does not allow, if Rust does not allow you to change the value of a variable, it will be very difficult to program. So how do you make a variable mutable? So there is a keyword MUT, which is a shortcut of mute. So you just say let mute infer type is equal to 12, okay? And then see here, you can change the type. I mean, you can assign the value here. A mutable variable's value, of course, it can be changed. Okay, so let's say mutable, it's 12, and you can assign a new value to it. Okay, the type of variable can't be changed. Okay, now this is important. So now here, see, this is an integer, right? Integer. But here now you're trying to assign a Boolean value to it. This is an error. You can't do that. Okay? Variables can be overwritten with shadowing. Shadowing means nothing but changing the type of the variable. And how do you do it? Let. Using the keyword let. Now, what does this do? Is now after the statement, the compiler would see the latest value. This 21 would be lost. Okay, but it would see this Boolean value, 21. This is called as shadowing, reusing the same variable name, but now giving it a different type. Okay, so from integer, we changed it to Boolean. So we'll see one code in action here. Again, as we talked about, mutability. Here, see, normally we have just given let x be equal to 5, and we are assigning the value 6. This is an error because, see, x by default, you have not given it the keyword MUT. So it'll assume, the compiler will assume this is immutable, and this will give you an error. So in order to fix that, you have to use the keyword mute, and this will run, the below code will run just fine. Again, the advantages of mutability, you all know, it's the same as all the other programming languages, where it gives more stability, more dependency in your program, more confidence in your program. Let's see this in action. So I have already downloaded Rust. So now this output is nothing but of the variable thing that we saw, the variable code. So let's see cat.rs here. This is the code that we saw. So the function name opens with a curly braces, ends with a curly braces. Different ways of assigning variables. Now let me edit it and let me give an error. Let's see how the error looks like, okay? Oops. I did not give, because that's an executable, right? So I have to modify the source file. Sorry about that. And come here. Now, when I compile and rerun this program, I should get an error here. Let's see. So how do I compile? Rust C. So expected integer, found bool, right? Here. So you get an error. You cannot change the type. Now, do you see here? For more explanation, try Rust C blah, 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 explain. Let's try this and see what we get. Here, expected type did not match the type received. So clear, right? This error occurs when an expression was used in place where the compiler expected an expression of a different type, right? It was expecting an integer. We got this. This is really one of the very cool features where it explains what is a problem or why did this problem occurred along with certain examples. Look at that, right? All right. All right, so let's fix the error, compile it, and run it again. Oh, sorry, here. So double slash is the comment. And now let's compile it again. There it is. See, again, there are certain warnings because it's just declaring variables. It's saying it's not used, it's not used, it's not used. So is just declare it this way. Again, helpful suggestions coming from the compiler. And now how do you run it? Nothing. I just added a print statement. Demo finished, which is here. Now let's go here. You can see the file. RS is there. And after compiling, it created the executable. Look here. It's an executable file, right? So this was nothing but the hello world kind of thing. And if I do here dot HW, what it is, nothing. Welcome to Rust programming. It has just that one statement. See, it just has this one macro, welcome to Rust programming. That is what we saw, right? In coming lectures, we'll go more in details. We'll use cargo for packaging, more advanced statements, control flow statements, how it works. Okay, so stay tuned. And thank you for your time. Thank you for listening. Bye.